Good morning, ladies and gentlemen. Welcome to our panel discussion on underground cables. Myself, Kavya, specialization in electrical and electronics engineering. Currently, I am in 4th semester in Tontadara College of Engineering, Gadag, Karnataka. I am excited to moderate this conversation with the esteemed panelists. So, let's joining me today are Yogish, Kavita, Chinmay, and Rehabul, who are all Triple E department. Together, we will be exploring types, materials used, construction, and innovations in underground cables technology. Okay, I will start with introduction about underground cables. The electric power can be transmitted or distributed either by overhead system or by underground cables. The underground cables have several advantages such as less liable to damage through storms or lightning, low maintenance cost, less chances of faults, smaller voltage drop and better general appearances. In underground cables, the voltage level is increases and the cost of the insulation level is also increases rapidly. The use of underground cables is restricted to low and medium voltage transmission. The underground cables also less dangerous to people because they are out of the way. Before we begin, I had like to take a moment to introduce our panelists. Now, let's dive into our discussion. I will start with by asking Yogish to share types of underground cables.
Types of underground cables. Underground cables are categorized based on the different criteria like based on voltage level. In that, low tension cable. Low tension cable voltage level up to 11 kV, while in case of medium and high tension cable the voltage level is up to 66 kV. Medium and high tension cable are 3 core cables. In that again there are 3 types: high tension cable, super tension cable and extra high tension cable. High tension cable voltage level of 11 kV. In super tension cable voltage level of 22 kV and 33 kV. Extra high tension cable voltage level of 33 kV and 66 kV. And next one is screen type cable. Screen type cable voltage level of 22 kV and 33 kV. In that again there are two different types of screen cables: H type cable and SL type cable. H type cable voltage level of 66 kV. Each conductor in H type cable is insulated with a paper. And SL cable. SL cable stands for separate lead screen cable. The voltage level of 33 kV. And the last one is oil filled cable. Cost of the oil filled cable is very high and long length of the oil filled cable is not possible in case of oil filled cable.
Materials used in underground cable. First material, rubber. Rubber is obtained from a milky sap of a tropical tree or oil product. Its dielectric strength is 30 kilovolt per mm and its relative permittivity is varying between 2 and 3. Maximum temperature is very low in rubber. It's about 38 degrees Celsius. Second material used is vulcanized India rubber. Vulcanized India rubber is made from mixing of a pure rubber and the compounds like zinc oxide, um, red lead and sulfur, and it is heated up to 150 degrees Celsius. It has the greater durability and wear resistant property. The sulfur reacts quickly with the copper, so tinned copper is used. Third material used is varnished cambric. This is simply the cotton cloth and coated with varnish. As varnished cambric is also hygroscopic, so need some protection. The varnished cambric is having dielectric strength about 4 kilovolt per mm and its permittivity is varying between 2.5 to 3.8.
And also next one is impregnated paper. It has a low cost, low capacitance and high insulation resistance and high melting temperature. The only disadvantage is the paper is hydroscopic. For this reason paper insulation is always provided with a protective covering. And next one is PVC cable. PVC stands for polyvinyl cable. This material has a good dielectric strength and high insulating resistance and high melting temperature. These cables are not so good for mechanical properties as those of rubber. And next one is XLPE cable. XLPE stands for cross-linked polyethylene. This material has a temperature range of 250 degrees Celsius to 300 degrees Celsius. This material is a good insulating properties. It has a light in weight, small overall dimension, low dielectric constant and high mechanical strength, and also low water absorption. These cables are suitable up to voltage level of 33 kV.
Insulation resistance is provided, which insulation resistance should be age as soon as it made, the age will get later, and the age of the UG cable must be potential, and when if it ages, then it destroys it. And if any harsh insolation or the chemical reaction is occurs, and in that there are electrical stress, mechanical stress and chemical stress. Electrical stress is over voltage and under voltage, and mechanical stress is start and shut down the sequence of the cable. And the chemical is which corrosion or vapor of the dust which includes in it. To keep that safety, we have used you should keep the better life of the cable, of the UG cable, which have been insulation resistance testing of it. Testing of insulation resistance of UG cable. Testing of insulation resistance is purpose of a good conductor, and there are mainly like 11 kV, 33 kV, 66 kV, and 110 kV. And alternative HV test insulation on the 11 cable, phase screen 1000 mega ohms, and the megger we have to take 5 kilovolt DC, and the resistance of insulation is 1000 mega ohms. And the 11 kV cable megger order result is 1000 mega ohms, and the 3-phase transmission line should be resistance must be 1.5 ohms. And I have used 11 kV cable for the for an example, like which I have been bought 95 cable, 11 kV cable, 11 kV case of this is a 5-coated sheet. First is main sheet, and second is steel sheeted, that armor, and it is also called XLP. And this is a copper sheet which is a protective, and this is a semiconductor, and this is insulation. These for testing this we have used 5 kilowatt megger, and in megger we have used positive and negative. In positive must be in insulation, and the negative must be on the semiconductor, to which we have been test. And for this healthy conductor we should use 1000 mega ohms for this, for the healthy conductor. If it is above 1000 conductor, then the conductor is not good. So these have been proceed to it.
Cable conductor is provided with a suitable thickness of an insulating material in order to prevent a leakage current. The path for a leakage current is radially through the opposition offered by a insulation leakage is known as a insulating resistance. There will be advantages in insulating resistance. It is essential to prevent shocks, short circuits, and other dangerous outcomes.
Grading of cable. We have seen that the stress in the insulation is maximum at the conductor surface and minimum at the sheath. To avoid the breakdown of the insulation, it is necessary to have uniform distribution of the stress at all of the insulator. Practically, some methods are used to obtain the uniform distribution of the stress in the insulation. The process of obtaining the uniform distribution of the stress is known as the grading of a cable. There are two methods of grading for cable. First one is use of intersheath for cable, and second one is capacitance grading.
Intersheath grading is a method between core and the lead sheet maintained in it, and provided in it all the maintained core sheet. Intersheath is having potential of tapping, and suppose there are 3 sheets, different potential for 3 sheets. Potential core potential is maximum, and the earth potential is 0. Voltage V1 and V2 are the potential of it. Voltage intershift 1 is respected to the earth. Voltage V2 intershift 2 is respected to earth. Disadvantage of it: complication fixing the potential intersheet, and the losses of the due to charging current, and the danger of damage while transportation of the cables. And intersheath grading is nothing but we use different sheet with different potential, unique uniform stress distribution to the intersheath, which we have been used intersheath grading.
Capacitance grading. It is also called dielectric grading. The grading is a homogeneous dielectric replaced by the layer dielectric having a different values on a stress
An infinite number of the dielectric will be required. The electric stress can be uniformly distributed by using a two or more dielectric suitable permittivity.
And last, the importance of underground cables are the underground cables keep people safe from electrical shocks and accident. They make cities look better by hiding ugly wires and poles. They are more reliable and need less maintenance. They help prevent electricity and theft tampering. Okay, I want to express my sincere gratitude to each of you for your informative discussions. It's been a pleasure to listening you. Your input has been so good and your participation made this panel discussion as huge success. Thank you for your time and thank you.